I'm Anil Kumar. In this video, we'll take a few examples where we'll talk about finding equation of tangents and normals, right? So these are the examples which I'm going to take one by one. The whole idea of finding derivative is basically to find tangents over the curves at a given point, right? So I've taken a few examples, rather compiled some of my videos to give you a variety which will help you understand how to solve such questions and prepare for your own test. Take it as a mid-chapter review of application of derivatives. So at this stage, you have learned the power rule for the derivatives and also how to find derivative of product of two functions, right? So those are the two things which you've learned. Based on that, you have to answer these questions. The very first question here is, find the equation of tangents from 318 to y equals to minus x squared plus 6x plus 5. The key word here is tangents. So you see more than one tangent here. That tells you something. This parabola, which opens downwards, kind of like this, if you check, 318 is not a point on the parabola. It is an external point, somewhere away, outside. You see that? So from a point which is outside, you can actually draw two tangents. And that's why you will see the word tangents. So that's a hint for you that you should check if the point is on the curve or not. If it is not on the curve, then the method is kind of different. You have to find the points where you can draw the tangent from the external point, correct? So this is a very special case where we are finding tangent to the curve from external point. There will be very few videos which will really discuss this aspect. So I'd like you to understand it and check few links. Then the other questions are kind of normal questions. Here, solve the quadratic equation y equals to x squared plus bx plus c, which passes through a point 4, 4 and has slope of minus 1 when x equals to 2, slope of 11 when x equals to 8. So we are given three different conditions, three unknowns to figure out. So that's not very difficult. Find the derivative first. Equate slope at a point. You get these two equations. Find a and b. To find c, use the point 4, 4. Correct? Third question here is, find an equation to the tangent line to this curve, y equals to 4x plus 8 divided by x plus 1. Which is perpendicular to the given line. So you need to find slope here, and then the perpendicular will be negative reciprocal. Derivative of this function, you could rewrite this as product of 4x plus 8 times x plus 1 to the power of minus 1 and apply the product rule, right? Since some of you haven't done quotient rule yet, right? That is our chapter 2.5. The last question here is, at what points does the line normal to the curve, which is a parabola, at point 3,5 intersects the curve? So of course it intersects at 3,5. Well, that's at least you can write. This is a parabola which opens upwards, kind of like this. So you'll find that the line which is normal to this point, kind of, will actually intersect at another point also, right? So it is normal. That means if I draw a tangent line, this is normal. So you have to figure out what is the other point. So find the equation of the normal and solve that with the given parabola to get the second point. So I hope this set of 4 videos will give you good practice and understanding how to apply derivatives to find equation of tangents and normals. I'll provide you with some additional links for extra practice. I hope that helps. Feel free to write comments, share my videos, and if you like and subscribe, that'll be great. All the best. The question here is, find the equation of tangents from 318 to y equals to minus x squared plus 6x plus 5. I hope you notice the word tangents. Now that clearly indicates that the point 318 may not be on the curve of this parabola. If the point is on the curve, you can only draw one tangent, not more than one, right? So let us test. If I substitute x equals to 3, I get the value of y as equals to minus 3 square, which is 9, plus 6 times 3 plus 5, correct? Now, minus 3 square is minus 9 plus 18 is plus 9, and 9 plus 5 is 14, right? So the point on the curve is actually 314, not 318. So 318 is an external point. So what I'm trying to say here is that this parabola, which opens downwards, can be treated like this. And we have a point which is outside the curve of the parabola, from where we can actually draw two tangents. So we have a point here, so we could draw a tangent like this, let's say, and a tangent like this. And this point here is given to us as 318, right? So this point 318 is right there. So let's call this point as P. Now any point on this curve will have, we can have value in general, x equals to a, and if x is a, then y value will be minus a square plus 6a plus 5, correct? And there is possibility of having two such points on the curve, which will result into two different tangents. So we'll find out the value of a, and then we will know really which are these points, correct? Once we know the points, we'll find equation of tangents. Now the strategy here is, we are given equation of the function, which is a parabola. Let's find the derivative. So derivative of this function is minus 2x plus 6. Now at x equals to a, the derivative of this function is going to be y dash at x equals to a is going to be minus 2a plus 6, correct? That is one thing. So derivative basically is the slope of tangent line. If I call the other point, this is my P, 318, and that's my point Q, which is on the parabola. In that case, what is the slope of PQ? Let's find slope of PQ with the formula y2 minus y1 over x2 minus x1. y2 minus y1, we can say 18 minus all this, which is minus a square plus 6a plus 5 divided by 3 minus a, correct? So that is the slope between P and Q, where point Q is x value of a and y value will be minus a square plus 6a plus 5, minus a square plus 6a plus 5, correct? Now that gives you, let's simplify this, we get 18 plus a square minus 6a minus 5 over 3 minus a. Now clearly these two slopes should be same, right? So y dash and MPQ should be same. So we can equate them and solve for a. So we can write this as, let me simplify this, a square minus 6a and 18 minus 5 is 13, right? So I'll write this as a square minus 6a plus 13, which is 18 minus 5 divided by 3 minus a, should be equal to minus 2a plus 6, the slope of the tangent on the curve where x is a. Let's solve this by cross multiplying. So we have a square minus 6a plus 13 equals to minus 2a plus 6 times 3 minus a. So we have a square minus 6a plus 13. If you open this, you get minus 6a plus 2a square. Multiplying by 6 gives us plus 18 minus 6a, right? Now let's bring all the terms together. Let me take them to the right side since we have 2a here. And as you can see, minus 6a, one of them gets cancelled. Okay. Now, bringing the terms together, we get 0 equals to, so we have 2a square minus a square. Then we have minus 6a plus 18 and minus 13 equals to 0. I mean, I've already written 0 on this side. So 0 equals to 2a square minus a square is a square. Here we have minus 6a, and then 18 minus 13 is 5. So plus 5. Now product of 5, sum of minus 6, it could be minus 1 and minus 5. We could write this as a minus 1 times a minus 5. So you get a as 1 and 5. So you get the point a as equals to 1 or a equals to 5, right? Now to find the x value, we can always substitute this value of a in the equation and find on this parabola what is y value, correct? So let me just make some room here for further calculations. So what we found here is that the value of a could be 1 or 5. Now if a equals to 1, then the parabola y equals to what? Let's calculate. Y will be equals to minus 1 square plus 6 plus 5. So which is minus 1. So that gives us plus 10. And so one of the points could be, let's say Q, as 1 and 10, right? The other point we'll try with value of a equals to 5. So if a equals to 5, in that case, y will be equals to minus 5 square, which is 25, plus 6 times 5, which is 30, plus 5. So it is 35 take away 25, and that is also 10. So, yeah. So 25, and this is 35, that is also 10. So the other point, let's say R, will be 5, 10. Correct? So we get 2 points at 5 also. Let's calculate. 5 times 5 is 25, 5 square, and 30 plus 5 is 35. So indeed that is also plus 10. So we get these 2 points, right? So these 2 points will result into 2 tangents. So now let us find equation of tangent PQ. Let's say Q is 110. And the slope at this point is going to be, for a equals to 1, the slope is going to be, let's write down the slope. We know y dash is equals to minus 2a plus 6. So minus 2a plus 6. Y dash will be equals to minus 2 times a is 1 plus 6, and that gives us minus 2 plus 6 is 4. So we get a slope of 4, right? Since we have to find equation of tangents from this point, so we have slope of 4, and therefore we can write equation of this line PQ. So line PQ can be written as y equals to mx plus b, slope is 4, 4x plus b, and since the point PQ, point Q is 110. I'll substitute 1 for x, 10 for y. So we have 10 equals to 4 plus b, or b is equals to 6, right? And therefore, PQ, the tangent equation, is going to be y equals to 4x plus 6. So that is one of the equations. Now let us find the second equation, which is tangent PR. Now for this tangent, we know that the point R is 510 and slope y dash is, let's find that out, y dash will be, since a is 5 for us, we'll substitute 5 here, minus 2 times 5 plus 6, which is minus 4, right? So the equation is y equals to minus 4x plus b. Substituting 5 and 10, we get 10 equals to minus 4 times 5 plus b, or that is 30, right? Minus 20, bringing it here. And therefore, the equation is y equals to minus 4x plus 30. So that becomes the second equation of the tangent PR. So I hope with this you understand that at times you might be given a point which is not on the curve. So you are in a position to draw two tangents as in this situation, and that's the way you can find their equation. So at times it can be complicated. I'd like you to go through this solution once again. This is a very important question from test point of view. Solve the quadratic equation y equals to ax squared plus bx plus c, which passes 4, 4 and has slope of minus 1 when x equals to 2 and slope of 11 when x equals to 8. You can always pause the video, answer the question, and then look into my suggestions. Now we are given the parabola in general form y equals to ax squared plus bx plus c. We are also given that at x equals to 2, slope is minus 1, and at x equals to 8, slope is 11. Correct? So to solve this, let's begin by finding derivative of this function. So in general, derivative of this function will be 2ax plus b. Now these two conditions will give me two equations. So y dash is basically the slope. So if I substitute the first condition, let us say, let me write this as condition number 1, this is condition number 2. So if I substitute the first condition, which is at x equals to 2, slope is minus 1. So m is y dash, right? So I get minus 1 here, and then I can write 2a and x equals to 2. So let me write this 2 here. I hope you get it, right? So we just substitute those values. And now we have an equation which is minus 1 is 4a plus b, correct? So we'll call this as our equation number 3. Now if I substitute 2, which is, let's say this condition, in our equation, then what do we get? Slope is 11, so I'll write this as 11 equals to twice 8, 2a times 8 plus b, right? So that gives me 11 equals to 16a plus b. So we get another equation. Let me call this as equation 4. Now these two equations both are in a and b, so we can always solve for a and b. So if I take away, if I do 4 minus 3, what do I get? So let's do equation 4 minus equation 3. So 4 minus 3 gives me 11 minus minus 1, which is 12. 16 minus 4 is 12, so we again get 12 here. So that is 12 equals to 12, or that implies that a equals to 1. So we get the value of a as 1, correct? Okay. Now we can find what b is. So we have a equals to 1. We can use one of these equations, which is minus 1 equals to 4a plus b. So if a is 1, then minus 1 equals to 4 times 1 plus b. And that gives us minus 1 minus 4 equals to b, which is minus 5. So we have values of a and b, right? So writing these two values of a and b, I can write down the equation as y equals to a is 1, so it is x squared. B is minus 5, so minus 5x, and plus c, correct? Now how do we find the value of c? To find the value of c, we know that the curve passes through 4 4s. We'll use the point 4 4, right? Substituting 4 for y and 4 for x, we get 4 squared minus 5 times 4 plus c. So that is 4 equals to 16 minus 20 plus c. Now 16 minus 20 is minus 4. So we get 4 minus comes this side plus 4 equals to c, which is 8, right? So c is equals to 8. So now we have found the value of c also. So we know in this expression a equals to 1, b equals to minus 5, and c equals to 8, and therefore the function is y equals to x squared minus 5x plus 8, right? So that becomes our answer, and that is the equation of the curve whose slope at minus 1, whose slope at x equals to 2 will be minus 1, and at x equals to 8 will be 11, right? So that is how we could solve this particular question. So you can check this. As a check, we can do y dash equals to 2x minus 5. And if I write x equals to 2 here, then 4 minus 5 is minus 1. And if I write 8 here, 16 minus 5 is 11. So it works, right? So that is how you could actually solve such a question. I hope that helps. The question here is, find an equation of the tangent line to the curve y equals to 4x plus 8 divided by x plus 1, which is perpendicular to the line x minus 4y minus 11 equals to 0. So perpendicular to the line, we will find slope of this line and then slope of perpendicular line. That's the first thing. So we are given the equation x minus 4y minus 11 equals to 0. Rearrange, we get 4y equals to x minus 11, y equals to 1 over 4x minus 11 over 4. So slope of this line is 1 over 4. Now what is the slope of perpendicular line? Slope of perpendicular line will be negative reciprocal, which is negative 4, right? So this is the slope we need. Now let us solve for this equation. Let's find an expression for the tangent of this curve. So let me take this up on the right side. So we are given the function y equals to 4x plus 8 over x plus 1. Now since we have only done, some of my students have only done product rule, they haven't done quotient rule, I'll rewrite this as product of two numbers, which is 4x plus 8, so two factors, x plus 1, correct? Now we'll find the derivative using product rule. So derivative of the first, which is 4, this is minus 1, times the second, which is x plus 1 to the power of minus 1, plus, we'll write this function as such, times derivative of this function, which is minus 1 times x plus 1 to the power of minus 2. So let's write them as rational expressions. We get 4 over x plus 1 minus, because of this, 4x plus 8 over x plus 1 whole square. Now you can take common denominator, which is x plus 1 whole square. We get 4 times x plus 1 minus, multiply these, okay, this is just 4x minus 8. 4x plus 8 I'll write in brackets. Okay. Now let's open the bracket. So we get 4x plus 4 minus 4x minus 8 over x plus 1 whole square. 4x minus 4x is 0. 4 minus 8 is minus 4. So we get minus 4 over x plus 1 whole square, right? So that becomes derivative at any point. Now we need to find equation of tangent line to this curve, which is perpendicular to that line, correct? So let's find slope of this line now first. So slope you can get by equating this to minus 4, right? So we'll solve this now. So we are equating this slope to minus 4. Since that is the condition, we want perpendicular to this line. So that will help us to find the point x. So minus 4 can kind of cancels out. So we can write this as, let me rewrite. So we'll first write minus 4 over x plus 1 whole square equals to minus 4. And that basically implies that x plus 1 whole square is equal to 1, correct? Dividing by minus 4. So if you solve this, what do you get? You get x plus 1 equals to square root of 1 plus minus. So that gives you two values of x. So we get x equals to minus 1 plus minus 1. Square root of 1 is that. So we get two values of x, which are minus 1, which is minus 2, and minus 1 plus 1, which is 0. So we get a value 0 or we get a value 2. So these are the two values of x. Substitute these two values of x to find the value of y. So we'll get the point on the curve, right? Okay. So if I substitute 0 here, let's write down. For x equals to 0, in this function, we get y equals to, if I write 0 here, I get 8. So one of the points is 0, 8 on the curve. For the other point, let me write x equals to minus 2. It is minus 2, right? Minus 1. X equals to minus 2. If I write minus 2, I get y equals to 4 times minus 2 plus 8 over minus 2 plus 1. Now that is 0, right? This is 0. So the point is minus 2, 0. So these are the 2 points on the curve. Now with these 2 points and slope being minus 4, we can write down the equation of the line, correct? So there are 2 different points from where we can write down the equation. So first equation could be, let's write down. So one equation where we'll consider the point 0, 8. Now 0, 8 is y-intercept, right? And the slope is minus 4, which is m, correct? So we have y equals to minus 4x plus 8, correct? So that becomes one equation. For the second line, we'll use the point minus 2, 0. So we have minus 2, 0, and slope is again the same, minus 4, right? So the equation will be y equals to minus 4x plus b, substituting 0 here and minus 2 for, 0 for y and minus 2 for x, we get b as equal to, taking it to the right side, plus 8, right? And if b is plus 8, we get the same equation, y equals to minus 4x plus 8. So basically, it is the same line which intersects this graph twice. Perfect. The question here is, at what points does the line normal to the curve x squared minus 3x plus 5 at point 35 intersects the curve? So that's the question for you. So we have the point 35. If I substitute 3 here, so we get 9 minus 9 plus 5, so it is 5. So the point is on the curve. Equation of the curve is y equals to x squared minus 3x plus 5. And what we are interested in finding is at what point does this line on the, which is normal on the curve, so it's kind of like this. It's a parabola which is, let us say, kind of like this, right? So if we have a normal to the curve, I exactly don't know where the points will be, but let me just sketch like this. So in that case, if I say this is my point, one of the points, then this point is normal at a given point, which is 3, 5. It does intersect somewhere else also. So the question here is, at what points does the line normal to the curve y equals to x squared minus 3x plus 5 at this point 3, 5, so if this point is 3, 5, intersects the 4, we have to find the other point. Correct? So that's the equation. We have verified that at 3, value of y is 5, right? 9 minus 9 is 0 plus 5. So the point is on the curve. Okay, so let's find equation of the normal. So for that, let's find slope first. So the derivative will be 2x minus 3. Derivative at x equals to 3 is 2 times 3 minus 3, which is 6 minus 3, which is 3, right? So derivative of the tangent is 3. So what is the slope of the perpendicular? Will be negative reciprocal, so minus 1 over 3. So we get this negative reciprocal slope. So we know slope of this line is minus 1 over 3. Let's find equation of this line, which will be, since the point is 3, 5, we could write this as y minus y1 equals to m times x minus x1, right? So which is y minus, y point is 5, equals to slope is minus 1 over 3, x minus 3. Cross multiply, so we get 3 times y minus 5 equals to minus x minus 3. Correct? So now we are going to solve this equation. So let's rewrite. Open the bracket, rewrite. 3y minus 15 equals to minus x plus 3, let us say, right? Okay. So equation of this line is, let me write in terms of y because we need to find the point of intersection also. So I'll rearrange this. So if I rearrange, I get 3y equals to minus x plus 3 plus 15. So y is equals to minus 1 over 3x, and 5 plus 3 is 18. So we get 18 divided by 3, which is 6, right? So this is basically minus 1 over 3x plus 6. Now we have the equation of the line, which is normal at this point. What we need to do now is to find point of intersection. So let's find point of intersection. We'll call this point as Q. So with line and the parabola. So let me substitute. Let's call this equation as 2. This as 1. So we'll 2 in 1. Basically equate the y values, correct? So let's do that. So we have minus 1 over 3x plus 6 equals to x squared minus 3x plus 5. Okay, bringing them all together, we have 0 equals to x squared minus 3x plus 1 over 3x plus 5 minus 6. So which is 0 equals to, that gives me minus 9 plus 1 as minus 8x, I mean minus is already there, over 3, and here we have minus 1. Now multiplying by 3, we get 0 equals to 3x squared minus 8x minus 3. Now we can factor this equation and find the result. Product is minus 3, so we could write this as 3x squared minus 9x plus x minus 3, correct? So let me just factor this now. We'll do it here. Taking 3x common, so we have 0 equals to, taking 3x common, 3x, x minus 3, and here we get plus x minus 3, right? Now x minus 3 is common, we get 3x plus 1 or equals to 0. So this implies that x could have two values. One, x could be equals to 3, the other value is x could be equals to minus 1 over 3. We already have 1.3 and 5, which we know. So the other values for x equals to minus 1 over 3. So let's find the y value. Okay, so we can use the equation of the line itself to find the y value. So we get y equals to, substituting minus 1 over 3 for x, minus 1 over 3 times minus 1 over 3 plus 6, which is plus 1 over 9, right? So when you multiply both negatives becomes positive. So 1 over 9 plus 6, 9 times 6 is 54, so we get 54 plus 1, 55 over 9, correct? And therefore the second point is x value of minus 1 over 3, y value of 55 over 9, correct? So that is what we get. So the point of intersection are, at what points does the normal of the curve intersect? So the points are this, minus 1 over 3, 55 over 9, of course 1 is already given to us, 3 and 5, correct? So that is how it could be solved. It's kind of tricky since the statement makes it kind of tricky, but I hope you understand when we say line normal to the curve, find the tangent slope, negative reciprocal, gives the slope of the normal, find equation of the normal, and then point of intersection, right? So I hope that helps. Feel free to share your comments. You may always subscribe my videos and share them with your friends. Thank you and all the best.